where chemical energy of fuel is converted into mechanical energy, and then mechanicals to heat energy. Okay, so whatever device you take, for example, in case of a pump, there will be conversion of electrical energy into the hydraulic energy or mechanical energy. In case of turbine, there will be potential energy of water into kinetic energy, then kinetic energy into mechanical energy into electrical energy, like that. So in all the engineering device, we are having one or other form of the energy transfer takes place. Okay, and we discussed various thermodynamic systems like a closed system, open system, and isolated system. Okay, in closed system, the mass of the system remains constant. The only energy transfer takes place between a system and surroundings. Okay. Uh, and in case of open system, there will be both mass and energy transfer takes place between system and surroundings. And in case of isolated system, there will be neither uh, in case of isolated system, there will be neither mass transfer nor energy transfer takes place. Okay. Example of closed system is the heating of uh, water in a closed vessel. Okay, the mass of the system remains same, but the energy transfer takes place between system and surroundings. And open system is all the engineering device what we are coming across are the examples of the open system. Okay. Isolated system, as you aware, thermos flask is the example of isolated system. And we studied the different thermodynamic process like constant volume process, constant pressure process, constant temperature process, adiabatic process, and polytropic process. Okay, these are the nature of curve. We studied constant volume process. The volume of the process remains same. Okay. The other properties like pressure and temperature changes. In constant pressure process, the pressure of the system remains same. Other parameters like volume and temperature changes represented by the horizontal straight line. And in case of constant temperature process, the temperature of the process remains same. And this is the nature of curve that is called hyperbolic curve. Okay. Because both pressure, volume changes, temperature remains same. And the equation for constant temperature process, PV equals to constant. How will get PV equals to constant means PV equals to MRT. M is constant, R is constant, T is constant. So together is a constant. That's why we are writing PV equals to constant in case of constant temperature process. And the fourth process is adiabatic process. Adiabatic process is a process where there is no heat transfer takes place between system and surroundings. Okay, so you should know the concept of temperature and heat. Temperature is a property of the system. Okay, and the heat is a form of energy. Okay, this is the difference between temperature and heat. And the heat which occurs by virtue of temperature difference. Whenever there is a temperature difference, then only the heat transfer takes place. Okay, so adiabatic process is the process where no heat transfer takes place between system and surroundings. And this is the equation PV raised to gamma equals to constant, where gamma is the ratio of specific heat. Okay, and it is given by Cp by Cv. This is the equation. You remember the nature of curve is same for isothermal, adiabatic, and polytropic. Only the difference in the equation. In case of constant temperature process, it is PV equals to constant. In case of adiabatic process, it is PV raised to gamma equals to constant. And in case of polytropic process, it is PV raised to n equals to constant. Then what is the difference between your adiabatic process and polytropic process is that case of adiabatic process, there will be no heat transfer. And in case of polytropic process, there will be heat transfer. The adiabatic process follows the law PV raised to gamma equals to constant, and the polytropic process follows the law PV raised to n equals to constant, where in case of adiabatic process, gamma is called adiabatic index. And in case of polytropic process, it is called as polytropic index. Gamma is always ratio of specific heats, that is Cp by Cv, whereas n is called as polytropic index, and it's not a ratio, just it is a constant, and the value of n is 1.2, 1.3, or 1.5, like that, according to the type of gas used in the system. Okay, so these are the 5 process we studied. Okay, next we studied thermodynamic process and thermodynamic cycle. So thermodynamic process is a process where we are going to take the initial state point, and it undergoes the number of intermediate states, and finally it reaches the final state. Okay, the initial state and final states have the different values. For example, suppose you take P1 is 1 bar, T1 is 25 degrees Celsius, and V1 is around 1 meter cube. So after going a certain expansion process, then it reaches final state 2. There we are having the different thermodynamic properties, like P2, V2, and T2 are different. This is called as thermodynamic process, where the initial and final states are having the different values. Okay, now coming to the cyclic process, it is, whatever you are seeing on the screen is the cyclic process. Okay, cyclic process is the process where the initial state and final states are same. So you see, I'm taking a process from C to A by following path B. Okay, having different properties. Initially, we are having the P1 V1, and as it reaches state 2, we are having P2 V2. Once again, taking back this state point to the initial state point by following path D, means when it reaches the initial state, so we can say that the initial and the final states are same. Okay, this is the difference between cyclic process and a thermodynamic process. In thermodynamic process, we are having the different state values, and in case of cyclic process, the initial state and final states are same. And we studied difference between adiabatic system and the polytropic process, homogeneous system and heterogeneous system. Homogeneous system is a system which is consisting of a single phase. Okay, for example, you take ice, water, air. These are all examples of the homogeneous system, because they are all in single phase. Okay, on the other hand, heterogeneous system is one which is having more than one phase. For example, mixture of water and oil. As you might have seen, the oil floats on the surface of the water because oil is having the less density as that of water. The density of water is 1000 kg per meter cube. The density of oil is 700 to 800 kg per meter cube, depending upon the type of the oil. Similarly, mixture of water and steam. Okay, steam always floats on the surface of the water. So this concept we are going to learn in boiler chapter. So steam is having the less density as compared to that of water. Okay, steam is having around 1 kg, approximately 1 kg per meter cube, and water is having 1000 kg per meter cube. So because of the density difference, so we'll get the heterogeneous system. And next we studied zeroth law of thermodynamics. Zeroth law of thermodynamics states that when a body A is in thermal equilibrium with body B, and also separately in thermal equilibrium with body C, okay, then the bodies B and C will be in thermal equilibrium with each other. Okay, first statement is important. So you have to draw this diagram. Whenever a body A is in thermal equilibrium with body B, and also separately in thermal equilibrium with body C, then the bodies B and C will be in thermal equilibrium with each other. Okay, so we are having a concept called as thermodynamic equilibrium. Thermodynamic equilibrium mainly consisting of 3 equilibrium conditions. One is mechanical equilibrium, second one is chemical equilibrium, and third one is the thermal equilibrium. Thermal equilibrium means the temperature of the system and surrounding should be same. Anybody, what do you mean by system and surroundings? Already studied. What is the meaning of surroundings? What is the definition of surroundings?
The environment around the object.
Hmm. Good. Okay. Everything external to the system is called as environment. The system is separated from the surroundings by means of a system boundary. Okay. So here you see the diagram. See, so we studied three systems: closed system, open system, and isolated system. We are having a boundary. Okay, whatever the things external to the system is called as surroundings. The system separates the surrounding by means of a system boundary. System and surroundings together, we are calling it as universe. System plus surroundings equals to universe. Surroundings is the things external to the system, and thermodynamic system, we are defining it as the quantity of matter or region in the space upon which our attention is concentrated in the analysis of a problem. That is the definition of thermodynamic system. Already you studied these three systems. Okay, so you should know the concept. Okay, and we discussed mechanics definition of work. Okay, so work is the form of the energy. As I said, thermodynamics mainly deals with the energy interaction. We are having many kinds of energy, like kinetic energy, potential energy. We are having nuclear energy, vibrational energy, rotational energy, displacement work. Okay, we are having so many forms of the energy, but in thermodynamics, mainly we are concentrating on the work and heat and energy. Okay, you should know the mechanics definition of the work. Already you know a definition of the work is force into displacement. Okay, so whenever a force acts on a body, it causes a displacement through a distance in the direction of force. Then the work is said to be done, and this work is equals to the product of force and distance traveled, or displacement. And product of force and displacement is the work done, and this is the mechanics definition of work. The unit of work is Newton meter, because we are going to express force in terms of Newton. Mechanics definition of work. Work done equals to force into displacement. When a force acts on a body, it causes displacement through a distance in the direction of force. Then the work is said to be done, and this work is equals to uh, force into displacement. Okay, and unit of work is Newton meter or joules. Okay, but in thermodynamics, we are going to define in a different way. Okay, so we are going to explain thermodynamics definition of the work by this experiment. So we are having a closed vessel. Okay, then so we are having a thermometer. Already know thermometer is a temperature measuring device. Okay, and we are having a pulley, stirrer. Okay, you see the stirrer. This is the stirrer. Okay, and a weight is attached to the pulley. Okay, and known quantity of the fluid present in the container. Okay, starting having the thermodynamic properties P1, V1, and T1. As you rotate the pulley, okay, there will be a fall of weight. Okay, so initially we don't have any moment. Okay, starting we're having the pressure, volume, and temperature. As you rotate the pulley, what happens? It causes the shaft to rotate. Okay, the shaft causes to rotate inside the fluid as the shaft work. So this is one form of the work in thermodynamics. As the shaft stirs inside the fluid, then what happens? There will be a change in thermodynamic properties. Means all the properties changing from P1 V1 T1 to P2 V2 T2. Okay, so because of this one, the change in thermodynamic properties. Okay. Uh, because of change in thermodynamic properties, it affects the environment. Okay. And as I said, surroundings, which is the external to the system, which causes the weight to move downwards. Okay. Whatever the sole effect on the things external to the system helps to move a weight for a certain distance. There is nothing but your displacement. Starting, we are having somewhere here. So as stirrer work takes place, there will be change in thermodynamic properties takes place, and this system interacts with the surroundings. Because of the change in thermodynamic properties, it causes the fall of the weight for a short certain distance. Okay, so that helps to cause a weight. So then how we are going to put it in the statement is the work done by a system on its surroundings. Okay, work done by the system on its surroundings. If the sole effect, how will get the sole effect? By rotation of stirrer inside the vessel. If the sole effect on the things external to the system is nothing but surroundings, could have been done by rising or dropping, means falling off a weight. This is how you are going to write the thermodynamics definition of work. The work is said to be done by a system on its surroundings if the sole effect, whatever change in thermodynamic properties inside the closed vessels, is nothing but sole effect on everything external to the system could have been done by falling of a weight. Okay, starting we're having somewhere here as the pulley rotates. Okay, as the shaft rotates. Okay, so there will be a dropping of weight for a certain distance. There is nothing but the displacement. Okay, this is how to define thermodynamics definition of work. Next, we studied the sign convention for work transfer and heat transfer. Okay, work is said to be done on the system represented by negative. Whenever work is done on the system, it is negative. The whenever work is done by the system is positive. Okay, so this is the sign convention and definition of the work. Okay, you remember work done on the system is negative, and work done by the system is positive. Okay, this is the form of energy. Next comes to your heat. Heat is a form of energy which occurs by means of temperature difference. Okay. So remember, the heat is a form of energy which takes place by means of temperature difference only. On the other hand, the work is a form of energy which occurs by means of difference of any parameter, like difference of pressure, difference of volume, difference of magnetic field. Okay, like that. Now we are having so many parameters in case of work done, but the heat is a form of the energy which takes place by means of temperature difference only. And this is a sign convention. As you add the heat to the system, it is positive, and as you heat take out from the system, it is negative. Okay, obviously whenever you add the heat to the system, the energy of the system increases. That's why we are going to represent by positive magnitude. Whenever you are going to take the heat from the system, the energy of the system decreases, so we are going to represent it by negative. Okay, remember the heat in thermodynamics is represented by symbol Q and the work by the symbol W. So this is a sign convention of heat transfer. Okay, and next we are having three modes of heat transfer. One is thermal conduction, second one is convection, and radiation. Okay, as I said, the conduction is a mode of heat transfer. So where the heat transfer takes place when the two bodies are in direct contact with each other, or within a body itself, the heat flows from higher temperature gradient to lower temperature gradient. That is the thermal conduction. Okay, the heating of metallic rod is a best example of thermal conduction. Second one is thermal convection. Convection takes place between the body and the surroundings. For example, when you heat the water in an open vessel, then the transfer of the heat takes place from the surface of the water to the surroundings, that is to the medium. So this kind of heat transfer is called as convection. Once again, we're having two types of convection. One is forced convection and another one is the natural convection. Natural convection means there is no force is required for the transfer of heat, and in some cases we need certain force to increase the rate of heat transfer. Certain devices like fan, blower are used to increase the rate of heat transfer. Such system is called as force convection. Force convection is it is a mode of heat transfer where the external devices are used to increase the rate of heat transfer. Example, fan. So by using fan, we can increase the rate of heat transfer. Okay, by using the blower also, you can increase the rate of heat transfer. But natural convection does not require any extra agents or any extra force. That is the second mode of heat transfer. Third mode is radiation. So without any medium, the heat transfer takes place between the two bodies. For example, the radiation from the sun through electromagnetic waves. That is the example of radiation. Okay. Next, sometimes they may ask difference between work and heat transfer. Okay. So first difference is work done takes place by means of difference of any parameter like pressure, volume, magnetic field, okay, displacement, etc. Okay, that is the work done. On the other hand, the heat transfer is a mode of energy which takes place by means of virtue of temperature difference only. Okay, no other parameter involved in heat transfer. Work done is represented by symbol W. The heat transfer is represented by symbol Q. Third difference is that work done on the system is negative and work done by the system is positive. In case of heat transfer, it is reverse. Whenever heat added to the system is positive, heat taken from the system is negative. And fourth difference is that we are having only the three modes of heat transfer like conduction, convection, and radiation. On the other hand, we are having the many forms of work transfer like we are having displacement work, stirrer work, flow work, magnetic work. So we are having so many forms of work, but we are having only the three types of work: conduction, convection, and radiation. And next difference is work done is a high grade energy and heat is a low grade energy. The work done can be completely converted, means 100% is possible conversion of the energy from work into heat, but the reverse is not possible. The complete conversion of heat into the work is not possible. So work is high grade energy and heat is low grade energy. So these are the differences between the work transfer and the heat transfer. Okay. Next, coming to important concept, that is the first law of thermodynamics for a closed system undergoing a cyclic process. Okay. So we are having basically four laws. We studied a zero law of thermodynamics. Next, we are going to study the first law of thermodynamics for a closed system. As we studied closed system, what is a closed system? That's why to understand first law of thermodynamics, you should have the idea of closed system and a cyclic process. Anybody? What is closed system and cyclic process? What do you mean by closed system?
Mass remains constant.
Mass remains constant. Good.
Energy will be transferred to system to
Hmm.
nature. Obviously.
Okay. Can you give an example of closed system?
Boiling water in enclosed
Okay,
surface.
good. Okay. What about the cyclic process? One more term is there, no? Cyclic process. What is the meaning of cyclic process? So just now I
The initial and final
So
state
in a
of the
cyclic
system is
process, the system.
uh, continue.
So the system returns to the same. The
Uh,
system returns to the same thermodynamic state.
Good. Okay. Correct. Thermodynamic process and cyclic process. Thermodynamic process is we are going to take from initial state to final state. Okay, which undergoes the number of intermediate states. The initial state and final states have the different values. On the other hand, cyclic process is the process where the initial and final states are in same condition. Okay. Can you tell me what is the integration of dV between the state points 1 to 2? We can call it as V2 minus V1, right? So integration of dV or integration of dP or integration of dt, we can write T2 minus T1, T2 minus P1 or V2 minus V1. That is a definite integral, but that work done is called as path function. That is not a definite integral. Now coming to the first law of thermodynamics for a closed system undergoing a cyclic process, you remember the first law of thermodynamics based on the principle of law of conservation of energy. Law of conservation of the energy is energy neither created nor destroyed. The total energy associated with the system remains same. Okay. And in the statement, it states that whenever system undergoes a thermodynamic cyclic process, then the net heat supplied to the system from the surrounding is equals to the net work done by the system on its surroundings. Okay, as you so you see the diagram here. Okay, compared to the system only, consider this as a closed system. So according to the first law of the statement, the net heat supplied to the system from the surroundings is directly proportional to the net work done by the system on the surroundings, or reverse is also possible, like the net amount of work done on the system is directly proportional to the net amount of the work transfer from the system. Okay, that is the heat and work are mutually convertible forms of the energy. We can take the work as input to the system and the heat as output of the system, or the heat as input to the system and work as the output of the system. Okay, so statement is whenever a system undergoes a thermodynamic cyclic process, then the net heat supplied to the system from the surroundings is equals to the net work done by the system on its surroundings. So this is illustrated with some simple experiment called as a Joule's experiment. Okay. So in the exam, just you write the statement enough. Okay. So this is just for your understanding. I'm explaining how you are. This is the proof of first law of thermodynamics. Let us consider a closed adiabatic vessel. So this is the insulated container. Insulated means there is no heat transfer takes place. We are also calling it as the adiabatic vessel. So this adiabatic vessel means no heat transfer takes place between system and surroundings. This known quantity of the water contained in a adiabatic vessel to be considered as a system, and surroundings, as we know, everything external to the system. And this vessel consisting of a shaft or paddle wheel with a pulley arrangement, and the weight is connected to this pulley. Okay, so this is the experiment, and thermometer is used to measure the initial and final temperature of the system. Okay, so this is called as a Joule's experiment to illustrate first law of thermodynamics in a closed system undergoing a cyclic process. Okay, this is let us consider a closed adiabatic vessel. You see, whatever this is enclosed by the adiabatic wall. Adiabatic wall is the wall which does not permit the flow of heat between system and surroundings. On the other hand, we are having one more wall called as diathermic wall. Diathermic wall is the wall which permits the flow of heat between system and surroundings. So adiabatic wall, which contains the shaft, this is what you are seeing. It is what you are seeing. It is shaft is connected with the paddle wheel, pulley, and the weight. Okay, and this is like stirrer only, and thermometer is used to measure the initial and final temperature. And here, so starting, we are having the thermodynamic properties P1, V1, T1. Okay, so it is represented by the X and Y coordinates. So we are having the PV coordinates, TS coordinates, and HS coordinates in thermodynamics. Okay, so just you consider it as X and this is the Y coordinate. Then how to represent the how the energy interaction takes place in the system. Okay, starting we are having the initial state represented by the state point 1 having the thermodynamic properties P1, V1, and T1. Okay. So now, okay, as the pulley rotates, okay, as the pulley rotates, the shaft also rotates. This is called a stirrer. Okay, as initially we're having P1, V1, and T1. As you rotate the pulley, the paddle wheel connected to the pulley helps to rotate the stirrer inside the fluid or inside the water. Okay. So what happens whenever the stirrer work takes place means the stirrer work process happens inside the closed system means the certain amount of the work is done, okay, to stir the stirrer inside the system. Okay, so that is represented by 1 to 2. Okay, so after stirrer work there will be a change in thermodynamic properties takes place. Starting we are having a P1, V1, and T1. When the stirrer rotates inside the vessel, then the thermodynamics properties takes place. Change in thermodynamic properties takes place, and it reaches the final state point to 2. Okay, so here we are having P2, V2, and T2. The T1 and T2 are the properties measured by thermometer here. Okay, so in order to reach the process from state point 1 to state point 2, a certain amount of the work is done on the system. Okay, that's why we have to take from here to here, because as I said, the work is done on the system is negative, work done by the system is positive. The negative work is you have to represent initial point is like this and final point is like this. Suppose if the work is done by system, you have to take in the reverse way, you have to take in the forward direction. If it is work is done on the system, you have to take in the reverse way. So starting point is 1. Okay, having the thermodynamic properties P1, V1, and T1. So whenever the pulley rotates, okay, the stirrer work happens inside the closed vessel. So because of this stirring works, there will be a change in thermodynamic properties takes place and reaches the final state point 2, where we are having the properties P2, V2, and T2. So it means in order to reach the state point 1 to 2, definitely there will be certain process happens. Okay, so this process is represented by W1 to 2. Okay, this is the representation of process 1 to 2 in XY coordinate diagram. Okay, this is the first step. Next, what I am going to do, I am going to remove the adiabatic wall. Okay, so just I am making it as a simple wall. Okay, so whenever you remove the adiabatic wall, can you tell me what happens whenever you remove the adiabatic wall? What happens?
Heat transfer takes place.
Hmm. Heat transfer takes place between.
System and surrounding.
Good. Okay, so next step, I'm going to remove the adiabatic wall. Okay, as you remove the adiabatic wall, the system interacts with the surroundings, because initially we had the adiabatic wall, there will be no transfer of the heat. But when you remove the adiabatic wall, so the system interacts with the surroundings. So the heat transfer takes place from the system to the surroundings. Okay, so that is represented by and after some time it reaches the initial state, means after some time both system and surroundings will have the same condition. Okay, and that is represented by 2 to 1. Okay, this see the curve. Okay, 2 to 1 is the quantity of heat transferred from system to the surroundings during the process 2 to 1. Okay, so hence process is, if first starting we are having 1 to 2, so with certain amount of the work done on the system. Okay, as you remove the adiabatic wall, so the system interacts with the surroundings, the heat transfer takes place between system and surroundings. After some time this process attains a common state, that is it reaches the initial state. So this is represented by the process 2 to 1, and you have to represent the process as 2 to 1. Okay, so here the work is done on the system, and the heat transfer takes place on the system. So this is the cycle completed by the two energy interaction. One is the work transfer, that is work done on the system, followed by a heat transfer from system to the surroundings. Hence, these two energy interaction constitute a cycle. We know that in a cyclic process, the initial and final states are in the same condition. Okay. So we can say that whenever a system, that is a closed system, this is the statement you see, whenever a closed system undergoing in a cyclic process, the net amount of the heat transfer to the system is directly proportional to the net work done by the system. Okay, or vice versa. Okay, so whatever the amount of the heat transfer to the system is directly proportional to the net work done by the system. You see cyclic integral, you see the symbol, one is integral. So when you put the circle over here, this is called a cyclic integral, that is summation of heat transfer. In the system we may have many number of the heat transfer. It is the cyclic integral or sum. Cyclic integral of dq is proportional to cyclic integral of dw. Cyclic integral of dw is nothing but summation of the work transfer. Cyclic integral of dq is nothing but the summation of the heat transfer. And mathematically, we can write it as cyclic integral of dq equals to some constant of proportionality into cyclic integral of dw. That constant of proportionality is represented by symbol J, and J is called as the mechanical equivalent or the Joule's equivalent. Anybody know what is the Joule's constant? Value of Joule's constant for water? You remember the value is 4.18 joules per kg Kelvin. That is a mechanical equivalent. Okay, so statement you should remember: whenever a closed system is undergoing in a cyclic process, the net amount of the heat transfer is directly proportional to the net work done by the system in a cyclic process. That is, cyclic integral of dq equals to a into cyclic integral of, and we are having another concept. You see, in the previous case, we considered closed system undergoing in a cyclic process. Now, I'm considering, I'm not considering the cyclic process. Okay, already you know the difference between thermodynamic process and cyclic process. Now, I'm considering just a thermodynamic process, not cyclic process. Okay, so just you consider a thermodynamic system in which the Q, that is the heat transfer into the system, and W is the work transfer from the system. Remember, it is the thermodynamic system without cyclic process. Just it is a thermodynamic process, any process. Okay. In this, Q is the amount of heat entered into the system, and W is the amount of the work done by the system. Okay. Then we are having the net energy. Okay. So net energy transfer is the Q minus W. This is the net amount of the energy, because as you take Q equals to W, according to the first law of thermodynamics, Q equals to W, the net amount of the energy is, you have to take the W towards the left hand side, it becomes minus W. So the net amount of the energy transfer is Q minus W, which will be stored inside the system. Okay, so the whenever the energy transfer takes place, Q and W between the system and surroundings, the net amount of the energy is Q minus W. That net energy stored within the system itself, and that energy is neither a work energy nor heat energy, but it is only the form of energy that we are calling it as the internal energy of the system. So many energy transfer takes place, and the net energy stored within the system itself. That net energy, whatever stored in the system itself, we are calling it as the internal energy of the system, and it is represented by symbol delta E. Okay, Q minus W is delta E, where delta E is change in internal energy. So delta E is nothing but E2 minus E1, that is final internal energy minus initial internal energy. The internal energy is also represented by another symbol U. Okay, so E and U are used as the internal energy of the system. 2 minus W equals to delta E. You remember, this is the thermodynamic process, just thermodynamic process, not cyclic process. Whatever the definition we did in the previous case, it is related to the closed system undergoing in a cyclic process. But whatever this I am explaining, it is only a thermodynamic process. First law of thermodynamics for a process. That is, whenever you are going to take the heat into the system and W out of the system, the net energy, that is Q minus W, will be stored or accumulated in the system itself. That is neither heat energy nor work energy, but it is called as the internal energy, or simply the energy of the system. Okay, and it is represented by Q minus W equals to delta E, and delta E is nothing but E2 minus E1, final internal energy minus initial internal energy, or we can write it as Q equals to delta E plus W. Remember, this is a simple formula to solve the problems. Okay, Q equals to delta E plus W. Q is the amount of heat transfer, and delta E is the internal energy, and W is so the form of energy. We are having the three forms of energy. One is heat energy, internal energy, and W is the work energy. Okay. So delta E internal energy is having the same unit as that of Q and W. We are going to express delta E in terms of joules or kilojoules. Okay. It is similar to our Q and W. It is the net energy stored inside the system, and it is neither heat energy nor work energy, but it is a form of energy. Okay. That is called as internal energy, and it is given by the formula Q minus W equals to delta E, or Q equals to delta E plus W. And you see this one, if there are more than one energy transfer takes place, you see, I am having here is W1 is the work energy taken into the system, and Q1 is the heat energy from the system, and then next W2 is the work energy taken from the system, and Q2 is the heat energy taken into the system. Like that, we can take any number of the work transfer and heat transfer. And how we are going to write? As I said, you have to concentrate on sign convention. So whenever work done on the system is negative, work done by the system is positive. Heat added to the system is positive and heat taken from the system is negative. Okay, so whatever starting I took, only one heat transfer and one work transfer. But in the system, there may be any number of the heat transfer and any number of the work transfer. Here, W1, Q1, you see, W1 is, if you have to write the first law of thermodynamics. Okay, start with Q1, Q2, Q3. So Q1 is taken from the system, means it is negative. You can write minus Q1 plus Q2 plus Q3. Okay, remember the sign convention, minus Q1 plus Q2 plus Q3 equals to delta E. That is change in intensity, and W is net amount of the work done. You see the sign convention, W1 is work done on the system is minus W1 plus W2 plus W3 minus W4. You see the arrow mark. Whenever the work done on the system is positive, work done by the system is positive, and work done on system is negative. Similarly, heat added to the system is positive, heat taken from the system is negative. Okay, so whenever system involves more than one heat transfer and more than one work transfer, we can write it as like this. That is, first you take this equation only, you can write Q means summation of all heat transfer. That is plus, sorry, minus Q1 plus Q2 plus Q3 equals to delta E, and W is minus W1 plus W2 plus W3 and minus W4, like that. So this is the first law of thermodynamics. Students, please all of you have to write your name in the chat box. Everyone, please enter your name in the chat box for attendance purpose. Everybody, okay. Everyone enter your name in the chat box. Totally there are 36 students. Okay, everyone enter your name in the chat box. Hope you understood all the concept in the thermodynamics. Okay, we studied first law of thermodynamics, zeroth law of thermodynamics, and in the next class we'll discuss second law of thermodynamics. Guys, all of you enter your revision fast, sorry, name.
Okay, we'll start the class.